All right, in this video, we're going to cover unions and intersections in probability. So we use, as you can see, Venn diagrams and also two-way tables in probability to help us understand what things have in common and what things don't have in common, basically. So I'll just quickly go through this, but it's also a good idea to put this information in your bound reference. Okay, so if you have a look at the Venn diagram, we have event A here. In the circle, inside the circle, we have everything that is to do with event A. So if we were to say, all right, the event is the number of vowels in your name, or how many vowels are in your name. So my name is Karen. So inside this circle, I would put the letter A and the letter E, okay, so because they're vowels. And then outside I would put the non-vowels, or we call it the complement of A. So that would be the K, R, and N. If you've got two events, so A and B, you could do the same thing. So event A could be vowels as well, and B could be the letter N. Okay, so, oh no, sorry, we won't do the letter N. We will do the letter A. Okay, so with your vowels, we have A and E in the word Karen, but because event B is also the letter A, so A would go in the intersection because A falls in both categories. Probably not the best example to use, but I'll use another example later to hopefully make it more, to make it clearer. Okay, so basically, if I go down here, it's probably a little bit better to see. So in your Venn diagram, in between here, we have A intersection B, so A and B. Inside this part, so not including where they overlap, we have A and not B, or A only. So the little apostrophe here just means that it's the complement of B or not B. On this side here, we have the complement of A or not A and B, so it's only B. And then on the outside, we have complement of A and the complement of B, so neither A nor B. And this can also be represented in a table. So this diagram here is probably good to have, and it's really hard to explain without actually having an example. So let's have a look at an example. Okay, so from a group of 50 adults, 35 enjoy fiction, 20 enjoy reading non-fiction, and 10 enjoy reading both fiction and non-fiction. Okay, so we have two events. We have F and N. So if I just quickly get my pen up. Okay, so we have event F is fiction and N is non-fiction. And I'm going to represent this as a Venn diagram and a two-way table. Now, I think a two-way table is easier than a Venn diagram, so I'm going to do a two-way table first. So on your two-way table, we have fiction and non-fiction. Oh, sorry, fiction and not fiction. And here we have non-fiction and not non-fiction. Okay. Have I confused you yet? So let's do our Venn diagram. Not our Venn diagram, our two-way table. Okay, so your table should look something like that. Oh, that wasn't too bad. Okay, now going back to our question. So we have a group of 50 adults, so your total always goes here. And that means this column and this row has to add up to 50. 35 enjoy reading fiction. So what we can do is say, all right, 35 enjoy reading fiction, so that can go here. Okay, so that's at the end here. 20 enjoy reading non-fiction, so non-fiction is here. And 10 enjoy reading both fiction and non-fiction. So this cell here is fiction and non-fiction. So for people who like reading all sorts of books. Now you can see we've got some empty cells here, but we can easily fill them in because this row here has to add to 50, so obviously 20 plus 30 gives you 50. This column has to add to 50 also, so that's going to be 15. This row has to add to 35, so we're going to have 25 here, 5 here, and 10 here. Okay, so we've got enough information in the question to do our two-way table, and I'm more confident with a two-way table than a Venn diagram. But once I've done my two-way table, I can then do my Venn diagram. You can also do a Venn diagram without a two-way table. Oh, it's terrible, isn't it? Much better at drawing straight lines and circles. Okay, so this one will be N. Actually, we'll do F first since I had F's just mentioned first. Okay, it doesn't really matter if you had it the other way around. Okay, so remember our intersection is both of them. So we're going to have 10 here. In here we have fiction, okay, fiction, but not non-fiction. So it's going to be 25. So in the whole circle here, we have to have 35. And then in this circle for N, we have non-fiction, but not fiction. And that has to add up to 20. And then on the outside, we have how many don't like either, which is 5. Now, all your numbers should add up to 50. So let's just check. 25, 10 gives you 35, and 10, 45, and 5 gives you 50. Okay, so see how, well, I can see how doing a two-way table is easier than a Venn diagram. But some people can go straight into a Venn diagram. Okay, so we've done the information on a Venn diagram. State the number of people who enjoy reading fiction only. Now, just remember here, this says state the number, and here we have the probability. So always check what the question is actually asking you. Is it asking you for how many or for the probability? If it's how many, you should have an integer, so a whole number answer. If it's the probability, then you should have a fraction answer. And remember, probabilities have to be between 0 and 1. Or, well, you can have 0 and you can have 1 as a probability, but your probability should be a fraction. Okay, so fiction only. So we want fiction only. So there's 25. Okay, so this 10 represents fiction and non-fiction. This 25 represents fiction and not non-fiction. And this 35 represents fiction for both. So we want fiction only is 25. Neither fiction nor non-fiction. So that's going to be 5. You can also read that from the Venn diagram here. Find the probability that a person chosen at random will enjoy reading non-fiction. So it doesn't matter whether they like fiction or not. So non-fiction is 20 out of a total of 50. Okay, so remember your probability has to be a fraction, so that's 2 over 5, or you can represent that as a decimal if you like, 0.4. Non-fiction only. So non-fiction only is here, and we don't want fiction, so it's going to be 10 over 50, which is 1 over 5, which is 0.2, and both fiction and non-fiction, so there we've got 10 as well. So 10 over 50 is also 0.2. Okay, so let's move along to the next one. Okay, question 2. At a show, 45 children have the choice of riding the Ferris wheel or the Big Dipper, 35, blah, 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 blah. Okay, illustrated as a Venn diagram. Again, I much prefer two-way tables, so I'm going to do a two-way table first. So we've got Ferris wheel, not Ferris wheel, Big Dipper, not Big Dipper. Okay, so, sorry, I should finish drawing my table. There we go. Okay, so we have 45 children, so the total goes here. 35 of the children wish to ride on the Ferris wheel. Okay, so 35 on the Ferris wheel. 15 children want to ride the Big Dipper, and 10 children want to ride on both. Okay, so now we can finish this off. That's the worst 5 I've ever seen. Okay, and then let's do the Venn diagram. Okay, so the intersection is 10. Then that's 5. Oops, what am I doing? Oh, let's label it first. I should have done that. So that's Ferris wheel, and that's Big Dipper. Okay, so 10 like both for the Ferris wheel. What have we got? 25. Did I do it around the wrong way last time? I'm trying to think. I think I may have. Anyway, Big Dipper. Sorry, just got a little bit distracted. Oh no, I did that one wrong. Hold on. I'm getting distracted. Hold on. Let me just pause for a sec. All right, I think I did it right. I'm sorry if I didn't. I can't really remember it. I'm not going to pause. Okay, so here we have the intersection of both. In here we want Ferris wheel, but not the Big Dipper, so it's 25. And here we want the Big Dipper, but not the Ferris wheel, so that's 5. And on the outside we want neither. Okay, so for this one here, see how we've got the N and the N, and this time we have PR. So in the previous question, it actually asked for the number, and this time it's got N or PR. So remember, if it's asking for the number, you give a whole number answer. If it's asking for the probability, it should be a fraction or a decimal, unless it's 0 or 1. Okay, so N, F only. So we want F only, which is 25 here, or 25 can be seen here. Neither F nor B, so that's 5. Okay, so for a child chosen at random from this group, find the probability. So the probability of F. So the probability of F is 35 out of 45. And you can simplify that, but I'm not going to simplify it now. Okay, so this means the intersection of B. So it's going to be the probability of F and B. Sorry, so it's 10. Okay, so this one is the probability of F or B. So the probability of F or B, okay, we didn't really cover that before. So I might just write it over here. Probability of F or B is equal to what you don't want. So 1 minus the probability of not F and not B. So we have 1 minus the probability of 5 over 45, which gives you 40 over 5. So you could add them all up and do it that way, but sometimes it's easier, or not in this case, but I just thought I would show you how you could do that. If we want it to be F or B, it means we want everything except for not F and not B. So it's 40 over 5. Then lastly, the probability of not F is 10 over 45. And you can go ahead and simplify those fractions. All right, just with this last one, I didn't have it on the screen. So the neither F nor B was 5 over 45. Okay, so question 3, from a total of 10 people, 5 like apples, 6 like bananas, and 4 like both apples and bananas. Draw a Venn diagram, draw a two-way table. Okay, so let's quickly do that. So hopefully you're able to do that now. So my two-way table, I'm going to draw a line. Okay, so we've got apples, not apples, bananas, not bananas, line, 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 line. Oh, missed a line. Okay, 10 people. 5 like apples, 6 like bananas, and 4 like both. So let's finish our Venn diagram. not our Venn diagram. Why do I keep calling it a Venn diagram? I'm still sleepy, so not functioning the best this morning. Okay, and then we've got A and B. Okay, so the intersection is 4, it's 1, and then that's 2, and then that's 3. So let's just count them up. 6, 10. Fabulous. Okay, so remember the number and the probability. So this is not A and B, so not A and B is 2. See how it's easier to read it off a two-way table? So that's 1/5 or 0.2. Not A, not B is 3 out of 10. Which is 0.3. Probability. Oh, sorry. I'm doing probabilities there. Wonder if you caught on to that. Sorry. See, that's why it pays to read the question. So that was 2 and that was 3. So it asks for the number, not the probability. Here we have the probability. So A and B, so is 4 out of 10. It's 0.4. And the probability of A or B means it's everything except for this one here. So you can count them up if you like. 6, 7 out of 10 equals 0.3. Or you could do 1 minus, not 0.3, sorry. 1 minus 3 over 10, which gives you 0.7. So you do it this way by adding up what you want, or this way by subtracting what you don't want. Okay, fabulous. Got close to 15 as possible. There's another video on worksheet 3 if you need it. Bye-bye.